All right, this is 3.2 worksheet A, and you may disagree with me, so I'll go through these and we'll decide what you think. Um, so we want to know, is it left skewed, normal, or right skewed? So this would be left, normal, and right. So ages of people in a care center, it's probably going to be right skewed. A lot of people pass away in a care center, so in the middle, we're going to have people that are in their 60s, 70s, and then there will be fewer 75s and fewer 80s and 85s, 100, 105, however long people live. So the first one is probably right. Number of siblings. Most kids would have how many siblings? None, one, or two, right? 3 is less common. 4 is less common. 5, 6. Malia, how many siblings do you have? She has 6. So that one is probably right skewed. Okay. Test scores on an easy exam. What's going to happen on an easy exam? Lots of people will pass and do well. Will some people fail an easy exam? Yes, but not very many. So left skewed. Are there any in particular you want me to talk about? Are there any in there you guys disagreed with? No? We're good? Making sense? Okay. So, when a graph is normal, if we have a nice normal curve, how does the median compare to the mean in a normal curve? The median and the mean are roughly the same. They're in the same spot. Okay? So if I am talking about height, if I add a very, very tall person, will the median move? The middle number? Yes. It will move to the right half of a person. Right? So if the median is a person, and we add somebody on the right side, then that median now becomes the average between the original median and whoever is next to them on the right. Will the average be affected by that super tall person? Yes. More than the median. So if this all of a sudden becomes a right skewed, if this is the median, then this is the mean. The average follows the tail. So, which is larger? Mean or median for test scores on an easy exam? The median, because that is a left-tailed graph, and the average follows the left tail, so the median is larger. Weights of newborn babies should be about the same. Right? We have lots of average-sized kids, we have some heavy kids, we have some light kids. It's probably symmetric. Okay? Number of minutes people wait in line at a grocery store. Do most people at the grocery store buy lots or a little? A little. Right? If you are going to buy a week's worth of groceries, how often are you going to go to the grocery store? Once a week, right? So the people who fill their carts don't come very often. But if you shop every day, how much are you going to buy per day? A small amount. So way more people go through the checkout with small amounts than large amounts. So large amounts are uncommon. So this is going to be right-tailed. So which is larger, the median or the mean? The mean. Okay? Does this make sense? Jacob said he understands, so it has to, it's clicking. Okay. All right, let's talk about variables. What is the variable for the sample mean? It is x bar. Sample standard deviation is s. Sample percentage is pi. That's from chapter 2. And population mean, this is what we're going to deal with in chapter 3. That is mu. our new favorite Greek letter. And then population standard deviation is sigma. Okay. Okay, these are tricky. So, if I have a population that is right skewed, and I take a sample, what is most likely going to happen with my sample? It will probably also be right skewed. Okay, I made it smaller because the sample is smaller, right? Okay. Well, what about the sample distribution? What does a sample distribution tell us? It is a histogram based off of the averages of many, many, many samples. So I do a sample, it's right skewed. You do a sample, it's right skewed. Is that a guarantee? Is a sample guaranteed to be the same shape as the population? No. It could be way off. Okay? So a sampling distribution is a histogram of the averages of many, many, many samples. What is the shape of a sampling distribution? It's normal. Now, this is every dot represents somebody's height. Okay? Does that make sense? And then here, every dot represents somebody's height. So every person in here is a member of the population, and we have given them a dot that represents their height. Okay? Every dot inside here is a person, and we have measured their height. But here, each dot represents the average of a sample. Does that make sense to everybody? I'm totally losing the back row. Yes. I didn't want to throw up. Hey, back row people. We're waiting for you. So in a sampling distribution, every point is the average of a sample. Does that make sense? So this graph is made up of people. This graph is made up of people. This graph is made up of samples, each containing many, many people, and we calculate the average from that sample. Which is why the sampling distribution does not have to look like, well, that's why it always comes out, not always, but most of the time comes out as a normal curve. Okay, so 28. A sample will usually have the same distribution as the population. True. If a population is skewed right, samples will probably also be skewed right. True, because of that word probably. 30. If the sampling distribution is normally distributed, the population is probably also normally distributed. True. Oh, wait. Sorry. If the sampling distribution is normally distributed, then the population is also probably normally distributed. False. That one is false. Does everybody get why? Okay. 31. If a large sample is normally distributed, the population is also probably normally distributed. So that's asking, if this is normal, then that is probably normal. That's true. 32. Wait, does somebody have a question? No? 32. If a population is normally distributed, each sample will be normally distributed. False. Probably, but it's not a guarantee. 33. For any population that is skewed left, the sampling distribution will also be skewed left. False. The sampling distribution will be normal. Right? This is always normal, regardless of what happens in the population or the sample. It is possible for a left-skewed population to yield a normally distributed sample. That can happen. Not likely, but it can happen. Especially if you don't talk to very many people. Right? If you only talk to 8 people, you're probably not going to get a good sample. Assembly distribution will usually have the same shape as the population. False. Assembly distribution is normal regardless of what the population looks like. A sample will always have the same distribution as the population. That's false. Okay. All right. 37. The collection of the average ACT score at Emory High for the last 20 years will probably be normal. Okay. Are ACT scores normally distributed? What do you think? So ACT scores. How many people get between 0 and 12? Not many. How many get between 25 and 36? Some, but most people are between 15 and 25, right? So this one would be, so ACT scores are probably right skewed. However, that's not what this question asks. This asks, if you look at all ACT scores from the last 20 years, that is a sampling distribution. Does that make sense? So each year is going to be right skewed. But the average for each year would be normal. Okay? The heights of adults in Emory County, probably normal. The age of all people in Emory County, definitely right skewed, right? We have lots of zeros and lots of ones and twos, but the longer people, the more people age, the fewer the people there are. Okay? A sample of the number of people in households in Emory County. Probably right skewed, right? There's that one family that has 8 people in it, the weirdos. 2 weirdos, 3 weirdos. You have 7. Oh, you can still be weird. Okay. 40. A sample, nope, 41. The average ages of many samples, each containing 300 Utahns. So an age distribution in Utah is going to be right skewed. But what if a whole bunch of us take an age sample, each containing 300 people? Then it's going to be normal because that is a sampling distribution. Okay. All golf scores at Millsite for the last year. Left skewed. Why? Lots of people have high scores. Very few people have low scores. Okay. So that would be left skewed. A histogram containing the average golf score at Millsite on 50 randomly selected days. That'll be normal because it's a sampling distribution. Right? The IQ of students at Emory High. Normal. But IQ is a normalized test. So whatever the scores are, we force it to be normal. Okay? Well, it's more like worldwide. Yeah, it's so if the average IQ this year is 100, what was the average IQ 50 years ago? 100, because it's defined as the average. So if people get smarter, the IQ doesn't go up. Like if the general population becomes more intelligent, the average is still 100 because it is defined as 100. So comparing an IQ from 2024 to 1800 might not make sense. because their 100 and our 100 might represent two different levels of intelligence. Okay, 45. The income of all adults in the United States. That's going to be right skewed. Most people are poor or slightly less poor, and there are very few rich people. The income of a random sample of 1,000 United States citizens. That's probably also right skewed. The average of 300 samples, each containing the incomes of 1,000 United States citizens. That will be normal because it's a sampling distribution. All right, hand that in.